Hello again, people. Today I'm going to be telling you about convection. So you already know that heat is transferred by conduction, convection, or radiation. Convection happens mostly in fluids. No, not like solids in conduction or electromagnetic waves like radiation. So convection, by definition, is the movement of heat through fluids, liquids and gases, or liquids or gases if you wish. So as particles are being heated up, as they gain energy, they move faster. And this makes that the part of the substance where they are becomes less dense and causes it to rise. I'll give more detail on this in a second. And this sets up a convection current. So here we kind of have the summary of what convection is, okay? Now, how does it happen exactly? Again, this particular slide is not mine, it's from Footprint Science. So how does it happen? So let's look at this. I have a flame here that is heating up the liquid, right? Now, the particles nearby the flame, because they are closer to the flame, they gain more energy comparing to the others, right? So what is happening is they are going to move away from each other because they are moving faster and faster. So this means that they are taking up, for the same amount of volume of the particles, I have less particles in that volume because they are moving away from each other. So what it's going to make is that the density of that part of the liquid is going to decrease. So less dense things, they rise. So the particles are going to rise to the top. Now, when they get to the top, they are far away from the heat source, so they are going to start to cool down because they are losing energy, so the particles start getting closer together. Now, if they are getting closer together, then the density, which is the mass over volume, so the amount of particles that I have in a certain volume, is going to decrease, so density decreases. So if density decreases, did I say decreases? Increases, sorry. If I get more dense, because I have more particles within the same space, then what is going to happen is that the particles are going to sink, because denser things go on the bottom, less dense things go on the top. So as they sink, what happens again? Well, they are near the heat source again. So the whole cycle is going to start over again, okay? So this sets up what we call a convection current. In gases is the same, just like liquids, okay? So imagine here, I have the radiator here in the house. Particles near the radiator, they gain more energy, thermal energy. This is going to make that they move faster, so they get more kinetic energy as well, meaning that they move away or further away from each other. The density of that part of the fluid, the gas in this case, decreases, therefore particles rise. Now, as they get further away from the heat source, the particles lose energy. If they lose energy, they are not moving about so much, therefore I have more particles per a certain amount of space, per volume. So the density increases, and therefore the particles are going to sink. And again, this keeps repeating, the cycle keeps repeating, and this sets up a convection current. The same you can see here in a pen. Oops, sorry, that animation doesn't work, so let's just forget about the animation. But here it is as well, okay? So hot water cools down, so cold water is going to sink, cold water is going to warm up when it's near the flame, hot water rises, and always the same cycle over and over again. So this is what I call a convection current. Common mistakes. Students saying that the particles lose density or that the particles become more or less dense. That is wrong. The particles have the same density. The particles are exactly the same. It's the area where they are, the space of that fluid, or so liquid or gas, that becomes more or less dense due to the amount of particles that I have in that particular space, in that volume, occupying that volume, okay? So be careful with this common misconception. Now, convection currents actually are the reason why you feel a sea breeze. So what happens is, and once I tell you about specific heat capacity, I can go ahead and explain this into a little bit more detail. But what happens is the ground, so it's a sunny day, right? And the sun is hitting both the ground, the land, and the sea. However, the ground heats up faster than the sea. So the air above the ground warms up and therefore rises because the air above the ground loses density, okay? So warms up and rises. This air needs to be replaced by something else. So cooler air that is from the sea, that is above the sea, is going to go and replace that air that just rose, okay? And again, that air that is warm later on is going to cool down and sink and then go back and then replace the hot air that moves up and all these things. And you set up again a convection current, okay? So the sea breeze is due to the cooler air from the sea flowing to replace the warm air that is on the land. Finally, because sometimes you guys get 6 markers, I'm going to give you, using at least an exercise that I did in class, using at least 6 different steps, explain how convection happens in liquids. So this is what you could have done. This is a model answer. When the liquid is heated up, the particles in the liquid gain more kinetic energy. Because the particles have more kinetic energy, they will move around faster. This will make that part of the liquid to become less dense, because the particles move about more, taking up more space, meaning the number of particles in that amount of volume is lower. So the particles will rise, that part of the liquid will rise. Once the liquid is away from the heat source, the particles will lose energy. Therefore, the particles move closer together, taking up less space. This makes that part of the liquid denser, because again, density is mass over volume. I have less particles, now I have more particles in the same volume. So, the liquid will then sink. After sinking, it will get closer to the heat source again, and the whole cycle repeats. This is known as a convection current. So there you go. So, all said about convection, which sometimes is not being used in the new specification, but there you go. You have everything you need to know now about conduction, convection, and radiation will follow, okay? Up to my next video. I hope everything goes well, so be happy and healthy, and take care. Bye!